Yeah, hello again. We are back recording, and this part will be the talk of Owen about parliamentary questions using rags. And maybe Owen, maybe you wish to say something before you start the recording, if you wish, and then we can begin.
Yeah, thanks. I do cover a bit of an intro about myself in the video, so I'll just probably start it. And thanks so much for Paula's talk as well. I think someone in the chat wrote that they wish they'd seen that video a long time ago, and that's the same for me. If I had if I had seen that video, it would have helped out a lot with this. But hopefully, it covers some of the same concepts we just heard as well. But yeah, I'll just start the video now. Hello, everyone, and welcome to my talk at the SciNoj Light conference on parliamentary questions RAG evaluation. So, a bit about myself to start. For my day job, I work in government administration for the Irish government. This project and this work isn't related to that job at all. It stems more from my hobbyist interest in programming and in particular in Clojure for around 3 years or so. And a huge thank you as well to Daniel, who, I reached out to him about 2 months ago about the mentorship program, and he's been so supportive and helpful in this work in advance of the conference. And he helped me also connect with Egg Syntax, who's doing really interesting work on evaluating Gen AI at a much broader sense than I'm looking at here. But overall, yeah, it's the Clojure community in general, and specifically the SciCloj community, have been great. So yeah, the Irish Parliament, which we can see pictured here, one of the kind of main functions is that members can ask different ministers questions about the work their departments are doing. So different questions about public policy issues such as health or social protection or housing. For example, here are just a couple of recent questions about generative AI. One is about copyright protection for Irish authors in terms of the training sets, and then the other one's about the EU AI Act. So in terms of the data I was looking at, it's taken from the Irish Parliament website, oireachtas.ie, and there they have all the questions and answers that have been asked as publicly available information, and the dates range from January 17th, 2024 to March 21st, 2024. And there's no particular reason for this date range. It was just a small enough slice of data to try explore some of these questions with. That covered around 9,800 questions, and the data set itself is quite simple. It's just the question and then the answer to that question, the date it was asked, the topic of the question, the department, and then the URL. We're really only going to be focusing on the question and answer columns. So the main kind of questions I had in relation to this data was, could we create a retrieval augmented generated application to answer questions similar to those in the data set, or can a Gen AI model do that work? And then secondarily, can we do this with Clojure? And that was just a kind of question that arose throughout the work, because a lot of the frameworks and libraries in this area are in Python, so there was a bit of overhead in terms of translating some of that into Clojure. And then how reliable is it? And that's related to the kind of evaluation question, and especially in the context of public policy, you want the answers to be factually correct and not misleading. So then just some very basics about retrieval augmented generation. I'm sure most of you are aware, but all it's really doing is in a typical interaction with a large language model, you'll ask it a question and get an answer back. So RAG is just inserting a step basically in that process. So here you might have all your documents associated with, say, a domain or organization, or in this case it's just the previously answered questions and restoring them in a vector database. And we'll go through what that is in a second. And when we get a query, then it's just looking up the most relevant information into that query in the database and then giving that information to the model in order to help it answer the question. And yeah, the goal here is just try to shape the model's answers to fit your own, I guess, context or needs better. Not just relying on the training sets of the large language model, but actually providing it more maybe specific or more up to date context for it to answer. And then in terms of what do we mean by evaluation, what it kind of boiled down to for me, or at least the way I think about it, is it's kind of trying to figure out how to evaluate one piece of text in relation to another piece of text. So here we have some text that was generated by a model, a generative AI model. And on the right, we have our kind of target answer. This is what we wanted the model to produce. So, as you can imagine, like trying to figure out how to evaluate this in relation to this is not an easy task. One way to think about it, or there's a couple of ways, is in terms of deterministic approaches or semantic. So deterministic is just basically counting, say, or one way of thinking about, or one deterministic approach could be counting the words, say, in this response that match this response. So for example, in this case, it is this target text is actually captured totally in this response. So here we could say the generated answer has 100% recall score. So that means all of the text, all the target text we're looking for is captured in the answer. But then we can also ask, well, what about this extra information that's provided? Do we want to kind of capture that in our score? So that we could also call or think about the precision of this answer. So in this case, we could say it's around 50 or 60% precise, because only 50% of this answer is actually related to this answer. So they're kind of the two broad ways of thinking about it. One is recall and one is precision. And then we can also think about semantic evaluation, which is embedding the text in a vector and then comparing it in terms of the cosine similarity. But the kind of a more recent, or probably the most effective way of doing this, is actually using another large language model to evaluate the response. So here, for example, we can give the model our target answer, and then we can give it the generated answer, and then we can ask the model, given the context, is the answer correct, or is the answer misleading, or is the answer precise, or however we want to structure that prompt. But the general point is here is we're kind of offloading that work to the another model. And I guess we'll see as we go through, but the point here is that these kind of deterministic methods don't necessarily capture logical or nuanced parts of meaning, whereas the models do seem to be able to capture that. And then in a more general sense, when we think about RAG evaluation, there's kind of two areas we can think about. So one is our retrieval method. So when we send a query to the database, are we actually getting back information that's relevant to that will be helpful for providing an answer? So yeah, it's trying to think about how to make our information useful for the model. And then answer generation, we can think about also evaluating the model, I guess, the large language model itself, and what kind of answer it's producing, and think about it in terms of, is it staying faithful to what we provided it, or is it readable enough, or is it too long or too short, or so different kind of questions we can have about that. So yeah, moving on to the notebooks themselves then. So I kind of split it up across a few different notebooks. I'm not going to cover all of it here, but it's these will be available as part of the conference. Basically, it's just building the vector database. So building this, evaluating the retrieval, generating an answer, so that's the kind of RAG part, and then kind of evaluation of those answers. So I'm going to skip forward here to the vector database section. So here in this section, there's not too much to say because I depended quite heavily on this LangChain4j library, and for example, I used the embedding model there and their in-memory embedding store. And all an embedding is basically taking some text. So this is an example question, and just embedding it as a vector of numbers, um, and that's about it. And then just storing all those embeddings in a database. So this is just something to add it to a database store. And then when we want to look up a question, we we have a query, so we embed the query, and then we we check the database for matches to that query based on, again, the semantic similarity, or the kind of cosine similarity of two vectors. And yeah, the point here is really, when we're dealing with that kind of unstructured, strings of text, this is just a much more efficient way of looking up relevant information, and it also gives a kind of more reliable method of determining similarity, as opposed to just, say, using regular expressions or things like that. So it's a very efficient, useful way of trying to just capture similar language in the first place, which then we're going to send to the model, and it will kind of sort out the answer from that. So then just looking at, looking up, sending a question to the database. So this question, for example, is about EV charging points, so electric vehicle charging points at the state's airports. And when we send that to the database, these are the kind of 5 most similar questions that were in the database. So one is about, EV charging points, transition to EVs, older model EVs, and so on. And then what I was doing initially was basically, once we have those similar questions, go back to our original data set and find the answers to those questions. So this is going back to our original data set and getting the answers. So here, for example, this question is about passport services, and these were the answers that were provided previously based on the most similar questions. But one kind of quirk of this approach, or if people are familiar with RAG, this is a little bit of a naive or roundabout way of doing this. So just to quickly kind of visualize that, like, we have all these questions in a database, and we have a data set that links them, say, and we're looking for similar questions, and then trying to find the answers. But a different way to think about it is just ignore the questions altogether and just search for the information that's in the answers. So that's kind of what I moved on to for the next part. So that's when we're starting to think about how good, like, how do we think about how to measure how good this approach is versus, say, this approach. And again, this is the kind of naive approach. This was, based on, in practice, if there was a question I had to answer, I would look at the previous questions that were answered on the topic and then find the answers. But that might just be a limitation of the systems I'm engaging with. Why don't we just go straight to the source, straight to the answers themselves? So that's what we're looking at here. So here we just have some sample kind of test questions and answers. So here's something from the document, say, we want to retrieve. So this is about the 2019 GP agreement, and this extra funding that was provided, so 211 million. And a question we're going to send to the database is, what is the government doing to help improve GP services? So GPs are just a type of doctor. So this is quite a broad question, but generally what we're trying to get is this information. So that's the kind of thing we're going to be testing here. So at the moment, what the way we have it set up, this is what happens. So we have this question that we were just looking at. We get the matching answers in our data set, and this was the most similar question, say, and this was the answer that matched that question in the data set. And we can see here, this is actually not a very helpful answer. These ones are quite long, more detailed, might be more useful. But then say the fifth most similar as well also wasn't very helpful. So we'd want to maybe improve that. One way to obviously improve it is to remove these kind of answers, initially before we even load them. But another way to think about it is to move to actually chopping up the answers. So that's what I was testing here. So in just a quite a crude way, I just chopped up the answers into either chunks of 3 sentences long each, or 5 sentences, or 10 or 15, and then also the kind of full answers themselves. So each kind of vector database had this data, say, loaded into it, and we're going to test the retrieval against each of those. And what we're looking for in terms of the retrieval is basically what we talked about at the beginning. So the recall, so how much of the target answer is captured in what we pull out of the database, and then the precision, so how much of what we pull out of the database is related to the target answer, and then the intersection over union, which is kind of the balance of both of them. So after running those, I got this data set that, say, has the recall, precision, IOU scores for each of the 5 questions up above, and then for each of the kind of configurations. And then if we plot that, so the first kind of area is the recall, and as you'd expect, the more these methods are returning the most information, say, like the full doc. So this one is just return each document is like one of these, so 5 of these as opposed to, say, 5 chunks. So we're just getting a much higher volume of text in these approaches, and therefore the likelihood of capturing our target answer is much higher. So the recall kind of goes up with this much larger context window. But then on the inverse side, the precision goes way down because we're getting all this information that isn't related to what we're looking for. So, the smaller chunk sizes are far more precise than the much larger chunks. And then, the IOU is kind of the balance of both of them. We see the kind of chunk sizes of 3 or 5 might be the most optimal. So going forward, then I kind of, I abandoned this method in favor of this method, and this is the kind of the new DB, the new database store for the vector database. And then just kind of visualize what that looks like. So this question here is about how much investment was provided under the 2019 agreement, and these are the kind of chunks, the 5 most similar chunks to that question. So this, this was remember the information we were looking for, maybe. So that's 200, it's in that, it's in that one as well. And then if we just compare that to our previous method, which was this kind of thing of looking up the questions and then returning the answers, we get like a lot more information. And this might be fine, but I guess the thing you're trying to guard against is if there's some text in these answers that might, introduce ambiguity into the context, I guess. Whereas, if we have more precise answers, there might be more likelihood that the model will succeed in its responses. But it's really a balance between the two that you're trying to test for. So then moving on to the actual generation. So now that we have a way to get the context, all we have to do is pass that context to a Gen AI model. So here's just a kind of a prompt to preface the context, saying, I want you to answer this question using the context, and if you can't find the information, reply with, I'm unable to answer this question. So to just quickly show that, so the way the functions work in this notebook is, you start with some kind of map, and each function adds keys to that map. So for example, if you want to get the context for this response, so we have this question again about GPs in the 2019 Act, and we're using this model, and this is our retrieved context. And then we can just format a prompt if we wanted to just look at the prompt, say. So we have our prompt here, and then we have all our context that we've retrieved. So that's what we're going to send to the large language model, and then and that's handled by, we're just sending it to some kind of cloud or local model, like in this case it's Google, the Google API, and in that case we get back a map with an answer key that has the answer. And again, if we just want to view that answer, and again say markdown. So we get a quite nice short answer from the Google model, and that's the information we were looking for. If we try a different model, say, let's see, say 4.0 mini, maybe the OpenAI model. And again, similar kind of answer. And if we try answer or ask a question we don't know the information for, like say, how many speakers are at the SciNoj conference? Then it gives us our default answer that we told it to give. And that's basically the RAG generation. We're giving it some context, and we're asking it to provide an answer. So then we can move on to how we think about evaluating that. I'm not going to cover too much in this namespace or this notebook. I'm just going to say that I think I had it open there already, but I relied a lot on this GitHub repository. It's a Python repository, but they have a lot of really good blog posts down here. And the kind of 3 metric categories I talked at the start are all included here. And basically, so this was a kind of evaluation data set I had. And if you just look at one question, for example, how many households were in receipt of HAP payments in 2023? So within our actual data set, we don't have the information for 2023, but we do have the information up to Q3 of 2023. So one thing to maybe test would be, are the models, capturing that nuance at all? So just to kind of show one of those example answers. So this was a Llama 3.1 model, and it does understand that quite well. So it says it's worth noting that the data only covers up to the end of Q3 2023, whereas a much smaller, lower powered model gets that one completely wrong. It says it gets a different figure, and then it doesn't understand the Q3 part at all. So when we're thinking about the metrics, that's one way to think about it. How good are the metrics at capturing this error? So in terms of the deterministic metrics, these were taken from that Python repository, and they're just the things we were looking at already, like recall, precision, reading ease. If you look at the scores for that, so say the Llama one got a 60% in terms of F1, which is kind of a balance of precision and recall. So it got 59-60%, whereas the Gemma 3 one got 57, which is still quite similar to that score. So those deterministic metrics don't pick up this problem at all. Similar for the kind of similarity metrics, where we see the llama one got 94, which is very high. So this is 94% similar to our target our target answer, whereas this one is still around 78% similar, which is not that bad, I guess. So it's only really when we come to the large language model metrics. So this again is just using another model to check the answers. So this is an example of a prompt for faithfulness. So, and faithfulness is basically just evaluating whether the statement is fully supported by the context, and then respond with either yes or no. So it's either yes or no. Is this answer faithful to the context or not? So as an example, we give the model, context about the Eiffel Tower, and then a statement that the Eiffel Tower can be found in the center of London, and the response should be no. And then so then we also have a prompt to measure the correctness. So that's out of 5, how correct is the answer? And then the relevance. So out of a score of 3, how relevant is the answer to the question? So looking back at that same question, we can see the llama model did get a 1 or a yes in terms of faithfulness. So got yes, it was faithful. Whereas the Gemma one did get a 0, so it got a no in terms of faithfulness. And it recognizes that this figure maybe relates to how many tenancies had been set up since the scheme was commenced, and it recognizes the problem here. And similarly with correctness, then the llama one got 5 out of 5, whereas the Gemma one got 2 out of 5. And then for relevance, the llama one got 3, and the Gemma one actually also got 3, because I guess relevance isn't checking for accuracy, it's checking for how relevant to the question asked is the answer. So you can see here it does provide a specific number of households. Like the question was asking how many households, and it does try to answer the question, but it is totally wrong. But in terms of relevance, it got a high score. And then I compared those scores across the different models. So for example, that faithfulness, the Google models, which are the purple here, seem to do the best. And this is our Gemma one. It only got 2 out of 10 in terms of being faithful to the context. Yeah, and I'm just going to move on now because of time to the last part. So this section was just looking at trying to kind of add all the metrics together, so both the retrieval and the generation, and try to think about ways to evaluate the kind of end-to-end pipeline. One thing I did here is I used another large language model to build an evaluation data set, and that proved to be quite useful. So these are some of the questions it found in the database. So and they're quite specific, so good for testing. So on what date, for example, did these members begin industrial action? And you have to get the exact date, or which department, or what year, what is the name of the town, and so on. So what I wanted to test then was basically two things. So one was the prompt that we're using, and then the other is the kind of retrieval method. So going back to this, so seeing again, I guess, from the the generation side, does this have much impact? So the kind of 4 configurations were, one was our initial prompt with the chunked answers database. So that's our initial prompt with this kind of splitting of the information. The other was our initial prompt with the question database, so just using the previously asked questions, and then a kind of slightly altered prompt with both of those setups. And then in terms of altering the prompt, again, I was just curious to see if I made some very small changes, would it actually impact the performance much. So this was our original prompt, and then all I did was kind of removed, I changed citizen to user, and I removed the word please. So I just made some very small kind of stylistic changes, but nothing substantial in terms of the meaning. So again, I was just trying to see if those kind of very minute changes would actually impact anything. And then just looking at the results, so I'll zoom out here a bit. So looking at the results, so each one of these bars are the different configurations. So if I just look, for example, at these two, so A1 was, prompt A with this method of retrieval, and B1 was prompt B with this method of retrieval. So both of these are using the same method of retrieval but a different prompt. And as you can see, the prompt doesn't actually, the performance after changing the prompt doesn't vary that much. You can see that if we go through, it's kind of there's a slight improvement, but nothing too drastic, and that's a good result. That's probably what you'd want to see with a small change, just a small impact. But then when we look at, so for example, this is the green is this retrieval method, and the other color orange is this retrieval method. So when we change the retrieval method, it does actually seem to impact quite a bit on the performance. So this kind of pattern of, the first and the third are the retrieval based on the chunked answers, and the second and the fourth are the retrieval based on the question. So this kind of pattern, repeats throughout all the different metrics, and so on. Yeah. And yeah, that's about it. That's just an example of maybe a couple of things you could try look at evaluating. So then just to conclude here, so I think one of the main lessons was this importance of setting up the the actual information retrieval. So setting up the vector database in an optimal way, and also cleaning the data beforehand. So I did notice throughout this there was a lot of duplication, even though I tried to remove duplicate information, there was more work to do there. And generally, I'm not too familiar with this area, so it was new to me that the Google Gemini models seem to do quite well in this task compared to the other providers. And yeah, I found that in terms of actually one of the most interesting things for me was using, just giving a model all of the documents, say all the answers, and asking it to generate interesting questions. And that was actually a quite useful way to find out information that's stored in the database or in the kind of data set. And then the caveats are, it was a very small window of questions, so it would be interesting to see how this would work with, say, a longer period of questions, and how to handle, say, the more recent information versus older information. And then, yeah, some of the metrics were actually translated by me into Clojure, so you'd probably need to do more testing and optimization on that. And also there's so many different kind of things you can vary within the RAG architecture. So, whether it's the embedding model or the retrieval, or which model you're using to generate the answers, or which model you're using to evaluate the answers. And I didn't settle on, I guess, the best things to look at, but I guess I was just trying to make inroads into that task. And then to summarize, yes, we can create a RAG. It's this wasn't an innovative way to think about RAG. It's just a question answer application, so it was quite easy, straightforward. Can we do this to Clojure? Yes, I think it was for me it was enjoyable to do it in Clojure, but there was this overhead in terms of time, in terms of translating things from Python. And then how reliable is it? I was pleasantly surprised, I think, at how you could use some of these metrics to improve the answers. And a lot of this, can be subjective, but I found it useful. And I'm going to skip this because of the time, and finally just say thank you very much for listening, and these are my contact details. Thanks.
Well, thank you, Owen. And it's a really interesting talk. I have one question to start, and then maybe we can take questions from other people. I'm just curious to hear what was most interesting for you to learn in this process.
Thanks. Yeah, as I was saying at the end, I think the the way that the retrieval method and how that information is looked up can can change the quality of the answers at the end. And I enjoyed trying to improve that part because it's easier to kind of reason about than the models themselves, I think. Like when you're just sending something off to an API and hoping and praying for something versus, with the vector database, at least there's more traditional kind of coding work. But yeah, I think it was that retrieval process was the most interesting part to learn about for myself.
And do you see yourself working on this project more, or like expanding on it, or any of the themes in it?
Yeah, I think like I said, it's just a hobby for me, so I'll have to see. But again, as I was saying, maybe just that more longer time span of information and even seeing, for example, asking questions based on past years and things like that and how the information changes. And the other thing was that Python repository I was talking about, they have a useful kind of um, one of the things to think about, I guess, is like the cost and the time of using another model to evaluate all the answers. So they have another method where they kind of use these semantic or deterministic metrics to kind of filter answers that, do look fine. And then if the answer is, uncertain that it's fine, then they pass it on to another model, and that can save a lot um, of the kind of the time and the cost, I guess.
Great, thanks for sharing. And so I guess we'll open it up to questions from anyone else. That is, if anyone has any.
Yeah, and maybe I'll mention that uh, we have the Zulip chat for discussion of this session, and it is a discussion that will go on during this conversation and later on. And I'll share the link again. The link to the Zulip chat is now here shared here in the Zoom chat, and it will be good to follow up. And yeah, Owen, can I ask anything? Yeah.
Yeah.
Thanks so much for the talk. Um, so um, I think you have been exploring a few of those evaluation platforms, evaluation frameworks, which are mostly in Python. And I'm wondering if you would like to say more about some things you saw there that you would like to make easier for us in Clojure.
Yeah, I think the like that framework Ragas or there's a few of them. What they seem to do is combine a lot of different metrics and like I was showing there, I was just kind of importing some of them from Python. So those kind of more traditional natural language processing kind of metrics like the Rouge kind of scores or things like that, like having a Python or Clojure library with all that already built in would be nice. Just that kind of natural language processing part of it. Um, the rest of it is, I think, is quite easy or straightforward in Clojure in the sense that a lot of it's done through, APIs and it's just that kind of, having some kind of HTTP client. But it's that kind of more natural language processing part of it that was a challenge in Clojure, I think.
Were there any like interesting or just like thought-provoking pieces of information with regard to like the sort of balance between the programming that you were doing and the questions that you were like sort of going through in the parliamentary questions in general. Like, is there any like interplay between the actual like technology parts of what you were doing and how you might see this applied in government or to like government function in the future?
Yeah, yeah, as I said, it's not really part of my day job, and government moves quite slowly. But yeah, I think that was always at the back of my mind. And when I first started looking at these questions, one of the main questions I had was like a lot of the information is duplicated, and in a day-to-day sense, it's like a very common administrative task to kind of put these answers together. So there's kind of, if large language models could help streamline some of that, it would save huge amount of time for people. So yeah, I think it seemed like exactly the kind of task that could be helped a lot with a large language model. That it's just a very kind of rote copy pasting of that's what you have to do to actually answer those questions. So if it could be all in some kind of database, or it could be summarized by a large language model, it'd save a huge amount of time and in terms of those kind of business processes. Also, I thought it'd be interesting to apply the evaluation kind of back on those questions, like almost from a organizational reform perspective, like how good is the government doing at answering questions almost from the perspective of those evaluations, like are we giving too much information? Is it unhelpful? You could almost apply the evaluation back on the data set again, on the original answers.
Very cool. I think that that's a good idea, and I I'm kind of interested in the like multi-model systems that can do that as well. Just in, like having interviewers and different agents that kind of like correspond with each other and feed data back into each other. You create those systems. Um, and so, very cool. Does anyone else have any other questions right now? I don't have anything else myself.
I think one thing that was, I believe, so nice in this talk is that, Owen, you were sometimes sharing with us some specific topics that you know about and that were actually, part of the data. And it looked like a lot of your evaluation of the whole system was very much situated with your knowledge of, the public system you're exploring. And I'm wondering, how important you found that to actually know those questions and answers, and how difficult it was to evaluate those parts of the system which are less known to you.
Yeah, I'd say um, like it's so broad, the work of the government, that I would only be familiar with such a narrow part of it. But that's why I actually found it really useful, as I said at the end there, to like use the large language model to find the interesting information in it. And that was really kind of enlightening for me myself, just to, instead of me reading through a lot of the answers, and yeah, some of the areas I'd be familiar with, but some were totally new. Just getting a model to kind of help summarize that or help pick out interesting information. That was really useful for me as well. But yeah, the probably where the kind of domain side of it, or the domain knowledge side, would come almost in terms of if you're evaluating the style of the answer, or the like I guess the great thing about the a generative AI model is they can be quite like um, a comment that's often made is they're not very interesting in a sense. Sometimes the answers can be quite boring, like very middle of the road, you know, trying to please everyone. But that actually kind of fits perfectly in a government context. Like you don't want it to be too thinking outside the box or anything. You just want this very plain, simple, you know, answer. So I guess that's where it kind of overlaps with the domain a bit as well, just in terms of almost the style or the yeah.
Yeah, and maybe another question, if I can. Oh, I think somebody was going to say something. Sorry.
I was gonna just ask if people had any other questions.
Yeah, so I think the workflow you described was a workflow where you were involved, you and your knowledge in evaluating things, and and then one thing we could explore in the future would be, you know, user interfaces that would make the whole operation enjoyable for a human being exploring this kind of system, right? I think in this conference we'll have at least one example of a data analysis project where user interface is very much important, like in Svetomir's talk tomorrow. It will be very much about creating a workflow and a user interface. And was that something that would make your process easier if you could explore things with some additional tooling?
Yeah, I think the um, like what's there in clay was already really helpful, and just I think as people have mentioned earlier as well, like even just Plotly and things like that, like just I didn't show anything there, but I did, you know, explore some visualizations of the vector database as well. But I think clay is just, you know, so easy to quickly visualize things with. That yeah, I found it's already quite well set up for that. I guess do you mean something like having like a user input box or something and like that kind of interface?
Yeah, I'm wondering what would make a process easy and transparent to a user who is trying to evaluate a complicated system full of text, knowledge, and yeah.
Mm. Yeah, no, I didn't think about that, but yeah, it's an interesting question. Like, how could you visualize the different components and the interactions? And yeah, yeah. I don't have an answer, but it's an interesting question. Yeah.
Yeah, thanks. I think in a moment, Lorelai, what do you think? What do you think? Would it be good to take a break and then return to the broader discussion? Unless maybe Owen has some conclusion of this part. We have a few more
Well,
moments, right?
if we have a couple more minutes, would you like to go into the code and show us a couple of things? Like looking at some of the charts and how you generated them might be like kind of interesting. Like you were just talking about the UI, and I thought that one thing about your charts that I haven't seen in Clay personally is I haven't used any like interactivity where you can click the chart and have like the bars appear or disappear. So if you showed us that, that would be kind of interesting to me.
Yeah, I can with that in particular, that's I can't take any credit for that. That's just built into
Oh
to the
yeah,
table
totally.
plot. um, uh, I could show quickly the I don't know if I could share my screen. The kind of TSNE. Can I go to? So the other thing I didn't really get to show was just because it came up earlier as well, was kind of projecting the vector database, say, onto 2D space. So one way to do that is with this TSNE algorithm. So this, for example, is 3 different topics within the data set, and this is just a projection after 100 iterations. And then as you kind of increase the iterations, they separate out into their kind of groups. And the thing that was good about closure, I guess, is you can do that quite like, say, so this one was looking at, say, when we ask or when you add, like, look up a question in the database, like visualizing where that question sits in relation to the similar answers. So I don't know, a question like so if I go to that clay, so here we can see, that's the question we asked, and those were the matches, say the 10 most similar matches. And if you kind of, say, change like a lower number of iterations, you can kind of see, so you can play around with that very easily with closure. Or then like a 3D plot. And again, that was similarly just stuff built into table plot. Like, this is a kind of 3-dimensional version of that, where again, you can kind of just turn off things. So say that's the question that was asked, and then there are the matches in a kind of 3D space, and say that's the 100 most similar matches. And again, you can kind of the ability to toggle these is just built into like, that's I guess the kind of code to visualize that is just up here. It's very short code anyway, that's why I can't find it. Yeah, I guess it's just, I can't remember where it is, but it's very simple anyway with Plotly.
Yeah, I did know it was built in. I just didn't know like what the keyword for it was. I'm just kind of interested in that because I assume that there's something that you must have to like.
I think it's this color part. So
Mhm.
color adds the kind of legend there, and then you can automatically play with the different settings there. So it's that color keyword.
I'm wondering if I just never noticed it myself because I've definitely used that before. But that's cool to see and know. I'll pay attention to that. I suppose if no one has any other questions, did you have another thing to add?
No, thanks for your question, Jen, and thanks again to Daniel for all the work for the conference as well. Yeah, it's been great so far. The talks have been great so far as well. I'm enjoying it.